Around 4C2, right?
Yeah,
Unit 4C. Okay.
All right, so here's
still a good one to do, I guess.
Yeah, this is good. Graphing tangents is a little bit different than sine and cosine. So the first thing to remember is what your basic tangent graph is. So your basic tangent graph is going to go from negative pi over 2 to positive pi over 2. And then at pi over 4, what's the tangent at pi over 4?
Is that just the... Oh wait, that's
I can't. Should I just draw a unit circle? Because it's usually easier for me when I draw it.
I'll do it. I'll
is that
put
the
it on
root
here.
2 over 2, 1? Oh wait.
Yeah, so here's your unit circle. So the tangent, remember the tangent is going to be your sine over your cosine. So I'll write it in here in red next to the spots. So the tangent of this is going to be the sine divided by the cosine. So it'd be 1 over root 3.
Oh,
here,
this one, right?
Here the tangent would be 1, right?
Yeah.
Here the tangent would be root 3. You get how I'm doing this, guys?
Yeah.
Yeah, I think.
And how about this one? What's 1 divided by 0?
0. Oh no, 1.
No, that's undefined.
It's undefined.
Oh.
And what's 0 divided by 1?
That's 0.
That's 0. And so this would be negative 1 over root 3. This would be negative 1. And this would be negative root 3. And this would also be undefined. So this is where it's, and by the way, this is going to help us understand the tangent inverse function, why it's only defined between negative pi over 2 and positive pi over 2. Right?
Okay.
So look at how I'm drawing this graph. This is why I'm choosing to.
Oh, so that's the inverse. The negative.
Well, right now we're not doing the inverse, but I'm talking about how it does relate to the inverse. It helps you understand the inverse. So this is your basic graph of y equals tangent of x. Look at my points. At negative pi over 2, which is right here, it's undefined, and that's why I put a vertical asymptote in there.
Okay.
Got it? At negative pi over 4, right, which is the same as 7 pi over 4. Got that?
Yeah.
That's this one. It's negative 1. Do you see how it's negative 1 there?
Yeah.
Okay, you guys understand that? And then at 0, the tangent is 0. So there's going to be a point on the origin. And then at pi over 4,
okay,
it's 1. And then it's undefined at pi over 2. That's why I have another asymptote there. So what your graph's going to do is this.
Now I see.
So you're finding the relationship between the radians and the tangent.
Yeah, or you could,
in the graph. Okay.
Yes, that's right. Or you could have put degrees if you wanted to instead of radians. It doesn't really matter.
Okay.
But usually you guys usually deal with the radians, I think, now, right?
Yeah.
Yeah.
Okay, so
I had bits and pieces, but this kind of went just full circle right here, no pun intended. It literally did.
Yeah.
Wow.
So that's how the unit circle is related to these graphs, right? Now, let's talk about how you would graph something like this then. So let me just tell you the intervals are these. You want to have like your center point, and then you want to have your asymptotes, and then you want to have the point that's in between there. So those are your 5 points and 4 intervals, right? Remember how you did that with sine and cosine also?
Yeah.
Yeah.
The difference is this period is only pi, it's not 2 pi. So we're going to graph this by doing that same kind of a similar thing. We're going to find what your shifts are. So here is your, this goes up 3, right? This number affects your period. but instead of 2 pi over b, it's pi over b, because the period is just the period of a tangent graph. Look at my basic tangent graph to the right. The period of a tangent graph is not 2 pi, it's 1 pi. So your formula is not 2 pi over b for your period, it's 1 pi over b. Do you understand that?
Yeah. So
the period of this example happens to be 2 pi. And then this 2 here, what that just affects, look at this, guys. This is going to help you. This 2, if I stretch this, really gonna what's gonna be different? It's just going to be stretched more, right? So what happens is this point doesn't change. Your center point doesn't change based upon the 2 in front of it, the A, but these points do. They will. So instead of going over 1 from the center up 1, go over 1 up 1
2
times 2, which is 2.
Okay.
You understand that? And this
Yeah.
would be over
Yeah.
1 down 2. So
Yeah.
this
Over 1
point
down 2 because
affects
of the.
this.
Okay, I think I see it. Wait,
So let me just show you what I'm talking about doing. So first,
why is it
I'm
over
going to
1
show
down
you
2?
steps.
Okay.
Find your center. This is your center right here. And to find your center, you're going to use your shifting up and down. Up and down or left or right, right? That's how you find your center. So what's my center point going to be in this example?
Huh. So would your
0,
center
0.
I'm
point
gonna
just be 0?
I'm gonna
Yeah.
do a different graph over here.
Okay.
So you can see. So my center point is going to shift. Instead of 0, 0, it's moved where?
It's
Up
moved
3.
up 3.
Moved
Oh.
up 3. So my new center point is going to be 0, 3. That's my center point.
Wait,
Okay.
I thought the -3 would be down 3 since it's like outside.
So sorry. Thank you. It's down 3, not up 3. Thank you.
Okay. Doesn't that also mean that then the graph
I don't know
flips,
why I
so
wrote
instead of
up
going
3.
positive, it goes negative?
Written up 3. I should have written down 3, obviously. My bad. Yeah. It's just been a long day, that's all. Absolutely, it goes down 3. Thank you, Gabriel. Okay, next, step 2 is we're going to find our interval lengths. Find interval lengths. And those are basically period times 1/4. What's my period?
Yeah. Period
For
is
this
pi
example?
over b value, right?
Yeah, my period, look, I already
It's 2
found
pi.
it. It's 2 pi, right? So
Didn't
this
you-
is 2 pi times 1/4. And what's 1/4 times 2 pi?
That'll be half.
It'd be pi over 2. So find interval lengths and label them. Okay, so let's label our interval. So I'm going to go 1, 2 to the right, 1, 2 to the left, and those are going to be, what are the lengths of these intervals going to be?
So this one I believe is going to be
No, just what are the lengths? What are
pi
the
over
lengths of those intervals?
2.
They're always pi over 2, right,
Yeah.
Gabriel?
Yep.
So this will be pi over 2.
From the
this will be
center, I
1.
go pi. This one is, yep, this first one is called positive pi over 2. And this is called positive pi. And then
And
to the
this is
left,
negative
it's negative pi over
and
2
then negative pi.
and negative pi. You get what I'm doing there?
Yep.
All right. And then the last step is just quite simply to, I'll put this in yellow, to plot your 2 points and asymptotes, the vertical asymptotes.
I have a question. So is it always going to be 2 points positive, 2 points negative? Because
Yep.
the way
When you're
we have
doing the
it.
yep, it is. For this
Okay.
for this graph, it always is, because there's always 4 intervals, which means there's always 5 interval markers.
Gotcha. Okay.
Okay. So
Okay.
there's my asymptote. Okay, now here's what, this might be the trickiest part, but it doesn't have to be tricky. Remember what I told you about this? You go over one, up one, and over one, down one for your base graph.
Mm-hmm.
So if your look at your amplitude to find those other points. What's my amplitude now? Instead of 1,
It's 2, so
it's
from here, would you
2.
go up to over 1 up 2 from here?
Yep.
And then
So over
over 2 up
1,
2
remember
down 2?
over 1 and up 2 and over 1 down 2. So these points are basically going to be here and here. So it basically stretched your graph out a little bit more than it would be. It didn't really change the shape of it so much. Like the general shape is the same, but it stretched it out. Look back at the red graph. It's kind of like if I had done it on this one, it would have been like this. Do you see how it stretches it more?
Yeah.
Yeah.
That's the only thing that you're doing with that A. That A doesn't change your center point. It just stretches out the other 2 points. Well, it stretches out all of the other points, but the only other 2 points that you're graphing are those 2. Okay, that makes sense?
Okay. Yeah.
Yep.
So I never really, like, I know that these are like where it's undefined or on the edges. Will they ever change like different points based on the graphs, or will it always be where 0, 1 would be?
Your asymptote always is 2 interval lengths away from your center on each side.
Okay, so it always will be 2. Okay.
Yep, if you're doing it this way, yep. Now the lengths are going to be different based upon your period, right? Those actual lengths might be smaller or bigger, but there's always, you're always putting 3, or you're always like labeling 5 points, just like your sine and cosine graph. The difference with the tangent and cotangent is the period is only pi, it's not 2 pi. So it looks the process is slightly different to calculate that period. So let's grab a unit circle and let's just refer to it as we do these problems. Okay, let's do those 8 problems on the left. So here's what this means right here. I'm not going to write it, I'm just going to say it so you can watch this video again. This means what angle tangent of 1. These are all looking for angles. No, not all of them. These ones are all looking for angles to see how they're the tan inverse, cosine inverse, arc sine, which means sine inverse basically. These are all looking for angles. That's what they want me to solve. So what angle has a tangent of 1? Well, the tangent is only defined. I'm going to show you this on my unit circle over here. Look at the unit circle to the right. I'm going to look at the bottom. I'm calling that, instead of 3 pi over 2, I'm calling it negative pi over 2, right? Okay,
Yeah.
good with that? And this is negative pi over 4. This is negative pi over 6. This is negative pi over 3. Okay, that's because I'm thinking of that as 4th quadrant, but I'm thinking of it as the 4th quadrant closer to, remember what we did over here? I'm thinking of it like this. See how that's my 4th quadrant right here?
Yeah.
That's what I'm doing. I don't want, this is my 1st quadrant. And so I want to use my 4th quadrant from 0 to negative pi over 2 so that it's the continuous graph. Because what I'm doing is I'm taking the inverse tangent of this, which means it's going to go like this. It's going to flip over the line y equals x. That's how you find inverse. That's how you find an inverse picture. Maybe you didn't understand what I just said, but that's okay. I'm not going to spend too much time talking about that. Let's just do these problems. So the point that I'm trying to make is the inverse tangent, tan inverse, is defined from here, here, going this way. Let me do that differently. I'll do it like this. It's defined from negative pi over 2, positive pi over 2. Tan inverse is defined. That's the range of tan inverse.
Yep.
Okay. The range of sine inverse
It's 1 and 2.
is the same. It's between here and here, but it includes pi over 2 and negative pi over 2. The tangent doesn't include it because remember the tangent?
Oh,
It's
yeah.
got asymptotes there.
Okay.
Asymptotes at negative pi over 2 and positive pi over 2, it doesn't exist there because the cosine is 0 for those ones. Okay, so the tan inverse is defined. I'm talking about the ranges, right? The ranges of the tan inverse is that blue right there. Got it?
Yep.
Yeah.
The range of the cosine inverse is from here, from 0 to pi. It's from 0 to pi. And that's because, again, if you were to look at the graph of that, let me show you. Let me add another page here and just give you a quick little reasoning behind that, because it's helpful for you it's helpful for you to see this. So here's my graph, my cosine graph. Remember the cosine, what I use red for that? It goes from here to here. Remember that? This is 2 pi. This is pi. This is pi over 2. That's 3 pi over 2. Remember what cosine does? It goes, this is 1 up here. This is -1 down here. So it goes like this. It goes through there and through there. Remember that?
Yeah.
Well, look at this right here. This is quadrant 1, quadrant 2. Do you see how the graph, the cosine graph, the positive values, positive, see how these are above the x-axis?
Yeah.
And also the negative values. There's positive, there's negative. So I can define my cosine inverse on this region right here, because that will cover all the positive and negative values I need to cover. I don't need to keep going because this is just repeating what was already here. And this is just repeating what was already here. And it wouldn't be a function if I kept going. What I just said was pretty deep. I know you might not be understanding that entirely, but it's okay. You can go back and watch the video. Now let's do the sine graph. It goes from here to here and goes through here, right? And it goes from here to there, right? And then it keeps going to the left, right? Because it's a periodic function, right?
Yeah.
So here's negative pi over 2, here's negative pi, here's negative 3 pi over 2, and here's negative 2 pi, right? And so your graph just keeps going. It goes like this, up, down, up, and here it goes down, middle, up, middle. Why do I have to define the sine inverse graph? Why can't I go from here to here for the sine? Why can't I go from 0 to pi for sine?
Because it's not a full period, and it doesn't end on pi. It ends on 2 pi.
Good guess though. Gabriel, tell me why I could go from cosine, I can go from here to here. What's different from 0 to pi of cosine versus sine?
The difference is that in the first quadrant, cosine is positive. In the second one, it's negative. Third one, negative. Fourth one, positive.
That's
meanwhile,
right.
Meanwhile, for sine, it's a little different because first one positive, second positive, and then the bottom two are negative.
That's exactly right. So from the first quadrant to the second quadrant, if I'm going this way, look what happens, Mitchell. This is positive and it's still positive. I don't want this. I don't see how these points are the same as these points. The y values are the same.
Yeah.
The y values are the same here. For instance, at pi over 4, it's 1. It's root 2 over 2, and it's a root 2 over 2 again. I don't want root 2 over 2. I don't want to get the same. I don't want the same answer. I want one of them to be positive and one of them to be negative. That's why I have to go here
Hmm.
This
Okay.
is the fourth quadrant. Go from negative pi over 2 to 0. That's the fourth quadrant. Those are my negatives. See how that blue is positive and negative?
Yeah.
And that's why my graph now. That's why the cosine or the sine inverse function, I have to, the range of that is from negative pi over 2, fourth quadrant, right? Positive pi over 2. But the cosine, I don't go there because for the cosine, look, the cosine is positive. That's the first one. It's positive in the fourth and the first quadrant. So I wouldn't define it here. I want to catch the positives for the cosine and the negatives for the cosine inverse. So see how my cosine is positive here and it's negative here?
Yeah.
For my sine, it's positive here and negative here. So I have to use those two quadrants as my range for my tangent and my sine for the same reasons. If that made sense.
Yeah.
Yeah, it does.
Okay. So now so why am I saying that? Because now I can do these problems much more easily by looking at this picture. What's the tan inverse of 1? Well, that means what angle has a tangent of 1? That's what that means. What
45.
angle has a tangent 1?
45 degrees.
The question. And what's the answer?
45
That'd be
degrees.
pi over 4.
Well, there's two, right? There's a
Yeah,
bunch. There's this one and there's this one. But which one do I want to use?
You want to use here?
You
let me
want to
grab
use
my
the first one
calculator.
because
You want to use
in
this
the third quadrant is not a part of the.
Right. I want to use the look at the yellow. I want to use this one, the one that's
Yeah,
in
it's not
here.
in the range of the third because the one in the third quadrant
That's exactly
is not in the
right.
range.
It's not in the
Okay.
range. So your answer is now. What do they tell you when it's like this? Do they want you to use radians?
Radians.
And this is
Yeah.
degrees, or what do they say?
No,
She
I think we
says
just
she
use
just wants
radians
us
for
to
all of them.
use radians
So
always.
it's the same thing basically. So some books say arc sine when they want you to do certain thing, and they do sine inverse for the other thing. But whatever. There's your answer. All right, for number 6, what's the arc cosine or the arc sine of 0? Well, what angle has the sine of 0 in this range, the blue? What angle has the sine of 0?
0.
0. Got it? What angle has a cosine of 1/2 in the first and second quadrant?
That would be this one, which is pi over 6, I believe.
Cosine's your first thing.
Oh wait, so that's the that's the 60.
So it's pi over 3. Got it, Gabriel?
Yep.
Gabriel, what angle has a sine of negative root 2 over 2?
Negative root 2 over 2.
In this region. Whoops, blue. In this
that
region.
It's gonna be in the fourth quadrant. So
Which is what?
315.
Don't say 315 because that's not in the range. Remember what I had to do? I had to change all these things to negative.
Yeah.
I'm going this direction. You're doing this. You're going all the way over here to this quadrant.
So it's just going to be a negative of the reference angle. So negative of 45.
That's it. That's exactly it.
Oh my God. I did so bad on my quiz today.
Negative pi over 4. Do you understand that?
Yep.
Okay. So for number 11, for this problem, we first have to find this angle. And we find the cosine of that angle.
So you got to find the cosine of -1.
So what angle has a tangent of -1?
The tangent of -1, would that be? I'm trying to read. Would that be that'll be this one, I believe.
Tell me what it is. Tell me what to write.
Is that is that pi over 2? Negative pi over 2.
Nope. Because that doesn't have a tangent of -1. What's the tangent? Tangent is sine over cosine.
Oh.
The tangent isn't even defined at that point that
Oh.
you just named.
Yeah, I'm confused on this one. So is this just so is this just gonna be undefined as the answer?
No.
Oh no,
Nope.
because
It's
it's trying to
negative
find the
root 2
cosine.
over root
Yeah.
2, which
What's the
equals negative
tangent?
1.
You guys aren't fine. You have to find this first. Gabriel, what's the tangent inverse of -1? In other words, what angle has a tangent of -1?
What angle has a
Yes.
tangent of -1? Out of these, it's gonna be in the fourth quadrant. So
Right.
it's gonna be. I'm not supposed to. -1. It is gonna be 45. So it's gonna be negative pi over 4.
Perfect. And so what's the cosine of negative pi over 4 now?
Cosine negative pi over 4. Square root of 2 over 2.
You got it.
Okay.
So that's
this
your
is gonna
answer.
stay positive. This is gonna stay positive, right?
Yep.
Oh yeah, it is.
Because the cosine is positive in that second quadrant or in the fourth quadrant. Okay. So what's this one asking?
Oh,
This one
I see
is
what
asking.
it's asking.
So first, remember, just like PEMDAS, right? You'll have to start inside the parentheses first. What you first do this. What is the sine of pi over 3?
The sine of pi over 3, that would be right here. So then the cosine of it.
So that's
is it
root 3 over 2,
Square root of
right?
3 over 2.
Oh, for the cosine. Yeah.
Root 3 over 2. Good. Now, what's the arc cosine of root 3 over 2? What
Would that
angle
be-
has a cosine of root 3 over 2?
That
So
would
what is
be
that's what confused me.
one-
What is the difference between
1/2.
just normal cosine and the arc cos?
Arc cosine means cosine inverse. That's the same. These things are saying the same thing.
Okay.
This is like saying cos inverse.
Okay. So it's just gonna So it's
So
gonna be
what angle has a cosine of root 3 over 2?
1/2.
Nope, that's
2
not
pi
an
over
angle.
3.
We're looking for an angle.
Negative 2 pi over 3.
Yep. So look at your blue, or sorry, your red. Look at the red over here. And what angle has a cosine of root 3 over 2? I think maybe you said it wrong.
Oh,
it's a
I see what
positive.
you're- I see what you're looking for now. Okay.
What did you say?
I was saying 1/2, but no, I see what you're saying.
Okay, so you're saying which one has so you're saying the positive, so it's gonna be pi over 6.
That's right. Here, let me.
Okay.
Maybe it'll make it easier if I write it like that. So this is an angle, right? That's an angle.
So
There's your answer.
So for 11, why was it asking for?
Hold
for,
on. I'm not doing. Oh, sorry. Go ahead. Go ahead with 11.
So
Yeah.
for 11, why was it asking for root 2 over 2? That's not an angle, but for 12, it was asking
Because
for the
look at what
angle.
11 is ultimately asking for. It's at the outer function is asking for a cosine, which is a ratio between. It's a number between -1 and 1. And number 12, the outer function is asking for an angle, because anytime it gives you this, it's asking for an angle. It means what angle has a tangent of 1? What angle has a sine of 0? What angle has a cosine of 1/2? What angle has a sine of negative root 2 over 2? Now this is saying, what's the cosine of this angle? So that's a ratio between -1 and 1. This one's saying, what angle has this ratio? What angle has a cosine, rather, of this ratio of root 3 over 2? Okay?
Gotcha.
Now, those ones were easy. Now we get to a harder one. The harder one is number 14, because that's not on our unit circle.
Yeah, that's the ones I'm really confused on.
Actually, let's hold off on that. Let's do 15 first because that's on our unit circle. So where's 13 pi over 3? Let me
That's
teach you
equal
how I
to
do that. You ready?
26 pi hours.
We're going to count by pi's over 3. Ready? 1, 2, 3, 4, 5. You see what I'm doing?
Yeah.
5 pi over 3, 6 pi over 3. You get what I'm doing?
Yep.
7 pi over 3, 8 pi over 3, 9 pi over 3, 10 pi over 3, 11. There we go. That's where it is. 11. Oh, I'm sorry. They want 13. 11 pi over 3, 12 pi over 3, 13 pi over 3. Now, an easier way to do that was to realize that, oh, hey, 12 pi over 3 is like going around the circle twice. Right? Because once around the circle is 6 pi over 3. Got it?
Yep.
You understand what I'm saying?
Yeah.
Once around the circle is 6 pi over 3. So twice around the circle is 12 pi over 3. So I have to go one more pi over 3 around the circle, one more 60 degrees. So this is the angle that they're talking about. This is the same as just pi over 3. What's the cosine of pi over 3?
1/2.
1/2. And hey, what angle has a cosine of pi over 3? I'm sorry. No, I did that wrong.
What angle has a cosine
of 1/2, not of pi over 3? What angle has a cosine of 1/2?
60.
Pi over 3.
Yep.
By the way, look what happens right here. What happens when you take the inverse of something? What happened when you multiplied? What's the inverse of multiplying? What's the inverse of multiplying by 2?
Dividing.
Dividing by 2. And what happens when you do that? Away. Stuff goes away. Remember that? What's the inverse of squaring something? Inverse of squaring something.
Yeah, square
the inverse function. Square rooting something. When I square rooted both sides, what happened to this 2 here?
It goes away.
It went away because it's the inverse. So look at this right here. What's going to happen when I do the inverse of a function? When I compose a function on itself, what's going to happen? They're going to go away. Catch that?
Okay.
So these really cancel each other. What really just happened here is they cancel each other out. Now, the only reason you can't just do that every time,
because there's 2 coses. I don't know. It's
the reason is because you have to have your answer in this region right here. Your answer has to be in the right region. It has to be between 0 and pi.
Okay.
So if I was asking what's the cosine of the cosine of like this one right here, 13 pi over 3. I think we lost Mitchell. If I wanted this right here, you see how I can't just cancel out these? I can't cancel these out. Yeah, hey, are you back?
Yeah, sorry about that. I got a blue screen of death, is what we call it.
So you can go back and watch what I was saying, Mitchell, later. You didn't miss too much. So Gabriel, these 2 right here, you can't just cancel those out because 13 pi over 3, so it's the same as pi over 3.
Yep.
Part of the red range for the cosine inverse. You get what I'm saying?
Yeah.
So your answer, I know you maybe would want to call it 13 pi over 3 as your answer, but that's not in the range of cosine inverse. So you have to find the coterminal angle for 13 pi over 3, which is pi over 3. So that's why this answer is pi over 3. Okay. Now let's do number 14 real quick. Okay. So for 14, remember, what does this mean? This right here means angle. This is an angle, right?
Yeah.
The angle that has a cosine of 5 over 8. Right?
Yeah.
And now they want us to find the tangent of that angle. So
Wait, but
what
I'm
we need to
confused on
do,
14 because what does 5/8 have to do with anything? Like that's not on a unit circle. So
right? Well, it doesn't have to be on the unit circle. The unit circle is just the 30, 60, 90 triangles and 45, 45, 90. That's a cheat
Okay.
sheet for your really nice triangles, but it's not. You certainly can find trig functions for any triangle. So what we have to do is we have to just draw this triangle in here. So here's what you have to do. Take your triangle and we're going to draw in this angle right here. We're going to find that angle, theta. What does cosine mean? Cosine is what? A over
adjacent over hypotenuse.
H. Right. So let's draw a triangle. We know this is going to be in the first quadrant, right? It's positive. Look it to the right. Cosine is positive in the first quadrant, right?
Yeah.
So let's draw a triangle in the first quadrant. Here's my angle theta. Got it?
Yep.
What is my adjacent? Where's my adjacent side? Which one of these sides of the triangle is my adjacent?
That
The
would
bottom
be
one.
yeah, the bottom.
The bottom is my adjacent. So just write in 5. And which side is the 8?
The opposite,
that would be the
so,
top.
Hypotenuse, right?
sorry,
So how do I
hypotenuse,
find this side over here?
Pythagorean theorem? There's gonna be 5 squared, so 25. 25 plus x squared equals
Good.
8 squared, so 64.
So x equals 64 minus 25. What's 64 minus 25?
49. So it's gonna be 7 because square root of 49 is 7.
Whoa, whoa,
So it's
whoa.
gonna be. Oh, sorry. What am I saying?
It's not 7 because that's not a Pythagorean triple. 64 minus 25. 39. There we go. That's why I'm using my calculator. So this answer is the square root of 39. You might be like, what? That's ridiculous. Why is it the square root of 39? Who cares? Who cares? What's the tangent equal to now? Look at my angle.
Oh, so
Tangent of
Katoa,
this angle.
opposite adjacent. So it's gonna be square root of 39 over 5.
Done. That's how you do those problems.
Oh, I wish I had the quiz tomorrow and not today.
Who do you have for a teacher?
Miss Tease too.
Oh, that's why.
All right.
Yeah, my quiz was today. I don't think it
Because
went
we have
so great.
ours. We have ours Tuesday.
Thankfully, it's not a test because the test is worth like 5 times more. So.
Well, yeah. Just make sure
I don't think we
this
have a
before.
test on this.
All right. You guys want me to do side here? What do you want me to do? Do these problems?
Sure.
Is that what you want? Let me undo that.
I feel like I also had more graphing ones on the 6th slide.
Yeah.
Okay, that's
you tell
that's
me what
great
you
to
want.
know,
We only have a couple minutes left. We have 5
I
minutes
thought
left.
all of these were unit circle ones, to be honest.
You want me to whip
That's
these
why I
ones
was-
off real quick?
Excuse me?
How about this one? I'll just do this one. How about this one real quick?
Sure.
So this is an angle. And let's draw that angle in. That angle is going to be in the first quadrant, and it's going to be a 3, 4, 5. So here's my theta. Here's my 3 because it's the opposite, right? Opposite. And here's my hypotenuse. So this is 4. Oh, that's easy. So what's the cosine? 4/5. This one's trickier down here because it's 24 and 25. But isn't there like 7, 24, 25? Isn't that a Pythagorean triple? 7, 24, 25. Does that ring a bell?
I'm guessing it is, but
3, 4,
I
5
don't
is one of them.
my...
We know that one.
Yeah.
8. I can't remember what they are. Just Google Pythagorean triples, but I'm pretty sure 7, 24, 25 is 7 squared plus 24 squared equals 25 squared. Pretty sure that's true. So what does that mean? Well, if I draw this, but here's the trick with this. See how it's a negative? It's in the second. That means it's in the fourth quadrant. It's down here. Right? So this is negative 24 and this is positive 25. So this is positive 7. So the cosine of this angle right here, theta, is adjacent over hypotenuse, 27 over 25.
Okay.
Okay?
Okay.
All right. Let's see. I got 2 minutes. Let me try to do one of these problems for you. Which one you want me to do real quick?
It can just be the first one. Just one of the graphing ones.
Okay. So we did one of these before, right? Oh, yeah. This is good because the key with this is to factor out that 3. So let's factor out that 3, and we're going to get cotangent 3 of x minus pi over 3 plus 1.
Okay.
So my point is going to go right pi over 3 and up. And then this 3 here is going to shift it as well, right? That's the period. My bad. Your period is going to be pi over 3. So your interval lengths are going to be pi over 12. Got it? You guys with me?
Yeah.
Yep.
So first step, right, pi over 3. So normally it would have started what your let me think. Am I doing this right? Shoot. I think I may have done that wrong, the other one. I think what you want to do is you want to start your interval. You want to start it at 0. I may have done that first cotangent one wrong. We'll have to go back and check that later. But what you want to do here is, I think what you want to do is shift from your 0, 0. I think you want to shift 0, 0 and start it on the left and then do your interval lengths. Also moving it to the right pi over 3. So instead of starting at 0, 0, I'm going to start at pi over 3. Now I'm going to move that, or I'm going to draw my intervals in here, and my interval lengths are pi over 12. So I'm going to think of pi over 3 as 4 pi over 12. Got it?
Okay.
So let's count by pi over 12. Here's 1 pi over 12. I'm sorry, here's 5 pi over 12 because I'm adding. Got it? Here's 6 pi over 12, which is pi over 2. Here's 7 pi over 12. And here's 8 pi over 12, which is
that's 3 pi over 4.
2 pi over 3, I think.
8 pi. Oh,
8
yeah.
over 12, divide by 4. Divide both by 4.
Yep.
Do you see how I did that, guys?
Yep.
So now I know that this is my center right here. I'm going to shift up 1. So that's my center point. Got it? And these are my asymptotes.
Okay.
And your cotangent graph goes like this. And because A is 1, it's still going to go like that. So I'm going to go up 1 and down 1 from there, up 1 to the left, down 1 to the right, and there's my graph. And to make sure I did it right, just for good measure, let's plug in, just to check, let's plug in pi over 2 into the formula. What's the cotangent of 3 times pi over 2 minus pi plus 1? Well, what's 3 pi over 2 minus 2 pi over 2? 1 pi over 2.
Yeah.
And what's the cotangent of pi over 2?
1/2.
Well, it's the opposite of the tangent.
Oh, wait.
And
It's
pi
2 over
over
pi.
2 as a tangent. Let me go to the unit circle.
It was undefined for that thing. So this is 0.
Oh.
Okay.
And that worked out. Okay.
I'm confused. How do you
Yeah.
find the vertical asymptotes
Okay.
though?
So again, the vertical asymptotes it's just a matter of shifting where I'm supposed to shift, and then using your interval lengths to find the next 4 points. And the asymptotes are the outer two of the 5.
Okay.
Gotcha.
Make sense?
Yeah.
All right. Well, hopefully that helps you guys out. I will edit that video on YouTube. I'm going to delete that whole section where I did this, and I'm just going to go back and I'll keep this one on there. Okay.
Okay.
All right.
Thank you.
I'm available Saturday in case you guys are wanting to find some more time. I'm available Saturday. Wouldn't be a
Okay,
bad
yeah,
idea
sure.
for you guys to, talk to each other and like buy back-to-back sessions, because you guys seem to work pretty well together.
Yeah, I
Okay.
know that I got a session for Monday.
Okay. Well, yeah, exchange phone numbers or something.
Okay.
Next to each other. You guys have each other's numbers?
I don't think so.
I would
Yeah.
recommend that. Maybe put it in the chat, or write it on this document. You've got that document open.
Okay.
Write it on the Jamboard or something, and talk it out, because you guys both of you really, I think, get a lot more out of an hour worth, and it's not going to cost you anymore. And you guys are both working on the same stuff. You know what I'm saying?
Yeah.
So, and you need more time with this. Both of you guys just need more time. You just need to practice a bunch of problems and get the hang of it. Okay. So Saturday, if you guys want, you can maybe sign up, or Mitchell, if you want to move one to Saturday. I don't know when your test is next week, but if you'd rather go Saturday, just put some
I don't have
Saturday
a test
sessions.
on this unit. We're starting unit 5 next week. I don't have a test not this week because we have like a 4-day weekend after this week. We have like Monday, Tuesday, Wednesday. We have a 4-day weekend. So
Right.
I have a test like 2 weeks from now.
Yeah,
But
we
it's
have
gonna be in unit. It's gonna be in unit 5. It's not gonna be in what we have now.
Yeah.
Okay.
We have
Well,
the quiz for this on Tuesday. So
Sounds good. Well,
Yeah, I had
you
the
guys
quiz
can
on
do
this
whatever
today.
you want. You don't have to listen. You don't have to take my advice. But if I were you, I would find other people that are kind of in the same boat as you are, and share sessions, because you get a lot more out of it if you do that.
Okay.
All right.
all right.
Sure.
All right, guys.
All right. Thank you.
See ya.
Yeah, thank you.
Thank you.